All right, this is the third and final video for Open Up Resources Unit 4, Lesson 3 and 4, Balanced Moves and More Balanced Moves. In our last video, I left you with solving these equations. Now we're going to look at ways that we can solve them. So, I need hands from students in the classroom right now. What did you do first in this equation? How did you decide to solve that? Emery? Yes, we can multiply both sides by 3. Here's the reasons why that's a good move to make. Do we have x in multiple places? No, not on this one. It's only in one place. Which means we could think about this kind of like a flow map, where we could say what's happening to x first. We are multiplying by 6, and then we add 12, and then we divide by 3. Which means when it's time to solve and undo those things, I'm going to start by multiplying by 3. And then we can also see what our next step is going to be. We're then going to subtract 12. And then we're going to divide by 6. Great. So I like that strategy. What's going on over here, though? There's some messiness over there, right? So before I start my solving steps, even though that's a great solving step, before I start my solving steps, can we simplify this first? Okay, let's do that. So 12 plus 6x divided by 3 is equal to 5 minus 9, negative 4, divided by 2 is negative 2. So now, when I am multiplying each side by 3, as Emery suggested, the right-hand side multiplied by 3 is a lot easier to manage. We don't have to worry too much about what happens here. The whole reason I'm choosing to multiply is specifically to undo that division, so I know that is taken care of, all undone. And it leaves me with 12 plus 6x. Is equal to negative 2 times 3 is negative 6. Should be good at this kind of stuff now, but we do need to make sure we're still careful with some negatives, which is going to be happening here. I subtract 12. When I subtract 12 from this other side, and I'm attending to precision, I end up with 6x is equal to a negative 18. Final solving step, we can divide each side by 6. And then we get x is equal to a negative 3. Now, I'm going to show you one other way that we could have solved this, which is not required for this problem, but remember I also forewarned you about your next task that's going to be pretty difficult and is going to require some extra directions. I'm giving you an extra strategy that you could use for a similar problem. So let me just rewrite this first. 12 plus 6x divided by 3 is equal to 5 minus 9 all divided by 2. That's just me rewriting the problem. And I really want your eyes on the screen so that you can see what's happening and why I'm taking this next step. Or I guess the first step since I'm starting over again. When we multiply by 3, let's pretend like we couldn't simplify this to a single number. Let's pretend like maybe there was an x here or something that was complicating things. So I can't combine the 5 and the minus 9 and then divide by 2 because I've got that x. Just pretend like that's a situation. We have these denominators that are really bothering me. We could think of them like fractions. And if I multiply by 3, it's going to get rid of this one. But if I multiply by 3 over here, it's not going to work out quite so nicely. What is a number that I could multiply both sides by that's going to take care of both of those denominators? 6, exactly. If I multiply this side by 2, it's going to take care of this, but it's going to be ugly over here. However, if I multiply both sides by 6, look at what's happening. 6 multiplied by something that's divided by 3. What is that 6 on the top and the 3 on the bottom really going to simplify to be? Sam? Not times 3, because everything is multiplied by 6, but then it's divided by 3. So what is that end result? 6 and then divided by 3. Times by 2, exactly. And what's going to happen over here in a similar way? Everything is divided by 2, but it's also multiplied by 6. So what happens when everything's multiplied by 6 and then divided by 2? What are we really multiplying by? 3. So take a look at that. See why that could be helpful on a different type of problem. Talk with your groups and figure out why did we choose 6. Whoever it was that shouted out 6, thank you. But figure out where that 6 even came from. Talk with your groups. Ready, set, go. All right, and where did that number 6 come from? Why is it that 6 works nicely on both sides? Kaden. Yes, we're taking both of those denominators, multiplying them together. If we want to know how to get rid of both of these denominators or divisors, multiply them together, you're guaranteed to be multiplying out those divisors. So again, what's really happening? 6 divided by 3 means I'm really going to be left with this whole side multiplied by 2. And over here, everything's multiplied by 6, but everything's also divided by 2. So this whole entire side, that 5 minus 9, is multiplied by 6 divided by 2 is 3. Now, of course, this is extra work for this problem because it's not necessary. We could have just simplified this other side, but I wanted to give you that strategy that's going to be helpful for other problems. Let's look at number 2. You have already solved it. What is the best way to solve this one? How else could I have done it? Talk with your groups and review it one last time. We're going to pause the recording as students talk. Okay, what's a good solving step, or what is a good simplifying step, or however you want to look at it? What could I do here? Daxton. Yeah, that's a good step to take no matter what. After I take that step, changing that subtraction to adding a negative, now what could I do, or what should I do? Tage? What do you mean by simplify the problem? How did you simplify it though? What did you do? Tell me what you did to simplify. Great. So what you're saying you did is you did this distribution. That's what you mean by simplify. You're doing this multiplication across the parentheses or using the distributive property. Yes, and so that is going to give us x plus a negative 4 is equal to 1/3 of 6x, which as Tage said is 2x, plus 1/3 of a negative 54 is, thank you. Now this looks a lot easier to handle. I'm still going to show you another way that we could have done this, but this is a great start. I don't like x on 2 different places, so I'm going to go ahead and subtract x. I'm sure you guys did something similar. That leaves me with negative 4 is equal to 2x minus x plus a negative 18. Now I want x all by itself, so I have these negative 18 unit tiles. I'm going to get rid of those negatives by adding in some positives. Balance it, do the same thing to the other side, and that's how I get negative 4 plus 18 is 14 is equal to x. But again, I would like to show you another way that we could do this problem. Again, not required for this one. You managed just fine without this strategy, but I want to show you strategies that are going to be helpful for your next lesson. A lot of times, students see fractions and they freak out. They don't like fractions. So we can get rid of this fraction right out of the gate. Yes, this problem worked out nicely that you could multiply this fraction across the parentheses, but what if it doesn't work out as nicely? What if instead of 6x, what if it was 5x? Would that have been quite as nice? No. And so, for strategy, or giving you strategies for problems that aren't written nice and pretty, this is going to work. How can I get rid of a fraction? Well, what's the denominator? It's 3. So what if I had 3 of those? 3 1/3. What is that going to be? 1. So I can multiply this whole entire thing by 3. That's going to get rid of this. But what do I have to do to keep it balanced? Just multiply like that. Multiply the whole entire thing by 3. So again, not necessary for this problem, but trying to give you some tips for success for the next lesson. Now, again, this multiplies out. So all I have left on the right-hand side is 6x minus 54. And on the left-hand side, 3 groups of x is 3x minus 3 groups of 4, so minus 12. We're still going to end up in the exact same place. Might look different right now, but we're going to end up in the same place. Negative 12 is equal to 6x minus 3x is 3x minus 54. Add the 54 to each side. Help me out here. I got 44, nope, 42. 42. Divide each side by 3, and that doesn't make sense. Did I make a mistake somewhere? 16, so I made a mistake somewhere. Oh, it's 14, right? It is 14, not 16. 42 divided by 3 is equal to 14. So again, not necessary for this one, but seeing other ways of looking at it is going to be helpful for the future. Last one. I think that there's probably only one really truly best way of doing this. What is the thing that you guys did on this problem? Let's see the hands. Thank you, Seth. Perfect. The opposite of 3x is going to be negative 3x. And the opposite of minus 12 is plus 12. And again, now that we've taken that step, everything looks nice and easy. Now that we've simplified everything. Add 3x to each side. So I can zero out the x's from this side, and now I have 12 is equal to 12x minus 4. Add 4 to each side. And I have 12 plus 4 is 16 is equal to 12x. Divide each side by 12. And we end up with 4/3. And fractions are friends, especially when it's a repeating decimal. Fractions are friends. All right, I'm going to show you what we're going to be doing in our next lesson to give you guys that head start. But first, let's finish up with our summary. Make sure you're highlighting along with me. How do we make sure the solution we find for an equation is correct? Why is there talking right now? I am trying to highlight and read through a summary. Thank you. Accidentally adding when we mean to subtract, missing a negative when we distribute, forgetting to write x from one line to the next. There are many possible mistakes to watch out for. Raise your hand if you have made any of those mistakes at any point. Yep, raise your hand if you made some of those same mistakes on the last test. Exactly, it happens. Fortunately, each step we take solving an equation results in a new equation that's going to have the same solution as the original. This means we can check our work by substituting the value of the solution into the original equation, checking our answers. So for example, let's say we have 2x is equal to negative 3 times the quantity x plus 5. When we take this step of distributing, we end up distributing the negative 3 to the x and the negative 3 to the 5. Now we have the new equation, which is the same as before. Then we're going to add the 3x to each side. 2x plus 3x is 5x, which is equal to 15. Divide each side by 5 and we get x is equal to 3. So this equation is the same as this one, as long as we've done our steps correctly. So when we plug in that x equals 3 into the beginning, we have 2 times 3, because that's 2 times x. Just taking that value of 3 and plugging it in is equal to negative 3 times x plus 5. Only now it's negative 3 times 3 plus 5. We can simplify. 3 plus 5 is 8. Multiply that by negative 3, we get negative 24. Wait, what happened? Is 6 equal to negative 24? No, that's not true. So we get a statement that isn't true. That tells us we must have made a mistake somewhere. Checking our original steps carefully, we see that we made a mistake. I don't know if you saw it before. I know Sam did. He raised his hand. Sam, where's that mistake? Exactly. They just did 3 times 15 when it's the opposite of 3 times 15. That should have been a negative 15. So when we make a mistake, when we plug that answer in, we see, wait a second, that's not true. So that tells us we made a mistake. Go back, check your work. We saw that we made a mistake when distributing that negative 3. Fixing it, we now have a correct equation. Negative 3 groups of x is negative 3x. And negative 3 times 5 is negative 15. So we change that to subtract 15. We then can add 3x to each side, so we still end up with 5x is equal to a negative 15 this time. Divide each side by 5, now we get x is equal to a negative 3. When we substitute that negative 3 in, so again, x is negative 3. Now when I plug in a negative 3, I get a true statement. 2 times a negative 3 is negative 6. X is negative 3, so plugging that in, negative 3 plus 5 is 2. 2 times negative 3, that time we got negative 6 on each side. That equation is true. So x is equal to negative 3 is the solution. Let's do the cool down. Lynn solved this equation incorrectly. Find the errors in her solution. This is math practice 3. We're critiquing her reasoning. One of the best ways to critique her reasoning is to construct your own viable argument. Maybe instead of just looking right at Lynn's steps, why don't you do your own work? Then you can compare. Maybe you can just read through the steps and figure out what the mistake is. Either way, I want you to find the mistake. Tell me what the new answer should be. Pausing the recording as you work on this. Ready, set, go. Let's just start with this. What should Lynn's answer have been? Who solved it correctly? Just a few students. Peyton, what do you think? Yes, it should have been x equals a positive 1/2. So, let's solve it ourselves and compare the work. Even though I'm going to be solving it myself and comparing the work, I'm still going to try and follow the same process. And so I can see that the first step that was taken is that they did simplify inside of the parentheses, which you should do, because we can combine 4 minus 17. So we have 8 times x minus 3 plus 7 is equal to 2x times 4 minus 17. Well, this 2x times 4 minus 17, we can simplify that. And when we do it correctly, 4 minus 17 is equal to nope, negative 13. So whoever said 13, you made the same mistake as Lynn made. Should be negative 13. 4 minus 17 is negative 13. Let's keep going. Now, it looks like Lynn distributed next, so we're going to do that as well. 8 groups of x is 8x, minus 8 groups of 3 is minus 24. Then we've got our plus 7 at the end, and over here they did 2x times a negative 13. Or in other words, negative 26x. You can combine these like terms. Negative 24 plus 7 is negative 17. So that works out. Looks like so far the only mistake that was made is just that pesky 13 should have been negative. Following that mistake all the way through is going to make a big difference. So, what do we do next? I'm not going to keep on doing this for you. What do we do next? We'll just keep on waiting. Thank you. And I think, is that Gabe's hand? Okay, Gabe. We add 8. Adding 8 gets rid of a positive. So 8x plus 8x is equal to 16x. Yeah, we should be subtracting 8x. You, Gabe, made the same mistake as Lynn. How did the 26 become a 34? Because they did add 8x. But is adding 8x going to zero it out over here? No, it's not. So you made the same mistake as Lynn. We need to subtract 8x instead. When I subtract 8x, it zeroes out, leaving me with negative 17 on the left-hand side, which is the same as what Lynn got. Over here, negative 26x minus 8x is equal to a negative 34x. Are we pretty close to what Lynn has? Yes, but we're doing it right. Mistakes are just having issues. Number 1, an issue with a negative. Number 2, they tried to undo with more addition. But adding 8x isn't going to zero that out. Now we can divide each side by a negative 34. And a negative 17 divided by a negative 4 is equal to a positive 1/2. X is equal to a positive 1/2. All right, we finally made it to the homework. After 3 videos, we finally made it here. Your practice problems are just here. A lot of it is like what we've done in class, solving, but also going through and finding mistakes in other people's work. And I think we're going to stop this video now. I think the next thing I'm going to do is either going to be in a new video or not in a video at all. So we're going to pause the video or end the video here. Thanks for watching.